Okay, so here's what we're trying to do here. We're trying to write a function, let's call it my log10 or something like that. So my log10 n, and what we want to compute is the log 10 of n. So for example, the log 10 of 1000 is 3, because 10 multiplied by itself 3 times, or 10 to the 3, is equal to 1000. So here's how I want to go about it. We're essentially going to say, okay, so is 10 to the 0 equals to 1000? And the answer is no, it's equal to 1. Is 10 to the 1 equals to 1000? No, it's equal to 10. Is 10 to the 2 equal to 1000? No, it's equal to 100. Is 10 to the 3 equal to 1000? Well, in this case, yes, it is. So in that case, the function should return 3. So the strategy is to kind of compute all of those guys and then say at which point do we reach the I for which 10 to the I is equal to 1000. So, okay, let's do that. So here's how I'm going to go about it. So I'll set up a variable res for result, and I'll set up the variable I. This would be basically the power to which we're raising 10 currently. So here's what I'm going to do. I'm going to say the result is equal to 1, and I'm going to say I is equal to 0. So now I'm going to use my while loop construct. So I'm going to say while, and here's the condition for I haven't yet reached the result that's equal to 1000. So what I'll say is while result is smaller than n. So if result is 1 or 10 or 100, and what we are computing is the log of 1000, I should keep going. So I'll say while result is smaller than n, I'll say result is equal to result times 10, and I'll say I is equal to I plus 1. After I'm done, I'll say, okay, so return I. So let's see how that's gonna work. So at first, let's say that we're computing the log of 1000. So that means that n is gonna be 1000. And let's say we call the function with 1000. So we'll say inside the main block, so inside the block that says name is equal to main, we'll say my log10 of 1000. So that means that this 1000 gets assigned to n, result gets set to 1, and I gets set to 0. N is 1000. So what we're doing here, so here we're saying repeat this block while this is true. And of course result is going to keep changing. So initially result is 1 and I is 0. And now we say, okay, so is this true? Well, yes it is. That means we need to repeat this block the once and then check again. So it says result equals result times 10. So this means that result is now going to be 10, and it says I equals I plus 1. So that means that I is going to become 1. Check again. Is result smaller than n? Well, yes, 10 is smaller than 1000. Well, again, multiply result by 10, add 1 to I. So this is going to be 102. Again, 100 is still smaller than 1000. So is result smaller than n? Yes. Multiply by 10. This is 1000, and this is 3. Check again. Is 1000 smaller than 1000? Well, no, it's not. That means we jump here, and we return I, which is 3, which is the right answer. So why did it work? Well, because this is the right thing to do here. What we're doing is we keep computing result, which is going to be equal to, at any point, 10 to the power of I plus 1 after you do this. And then you increase I as well. So eventually, result is going to be equal to n, and it's also going to be equal to 10 to the I, so we return I. So this makes sense.